Here is problem number 19. We are given an iterated integral. The function is not given, but the limits of integration are, and we're also given the order of integration. First integration is over y. Y ranges from 0 to 2x. And the second integration is over x, where x ranges from 0 to 5. The problem is asking to reverse the order of integration. In other words, we would like to rewrite this iterated integral so that the first integration is over x and the second one is over y. Now, the iterated integral that we are given calculates a certain double integral of the function f of x, y. So let's denote that region of integration by r. And so the given iterated integral calculates the double integral of f of x, y dA. dA is the differential of the area over the region R. And in order for us to be able to reverse the order of integration, we need to know what that region R is, and it would also help to have a picture of it. Okay, so now let's think about what our region of integration is. It consists of all points x, y, such that looking at the first integration in our iterated integral, which is integration over y, we see that the limits of integration are from 0 to 2x. Right? So the y variable ranges from 0 to 2x, and we can express that as an inequality. Y is greater or equal than 0 and less or equal than 2x. And the second integration is over x, where x is ranging from 0 to 5. So we have a second inequality. X is between 0 and 5. And the region of integration R consists of all points in the xy plane whose coordinates x and y satisfy these two inequalities. X is somewhere between 0 and 5, and then y is between 0 and 2x. Let's make a picture of this region. I'm gonna graph this region. So let's begin by graphing. Let's begin by looking at the first inequality right here. Y is between 0 and 2x. And we will graph the two lines, namely y equals to 0 and y equals to 2x. Now y equals to 0 is just the x-axis, and then y equals to 2x is a line going through the origin with the slope 2. And since we have the inequality which says that y has to be greater or equal than 0 and less or equal than 2x, therefore the points that satisfy this inequality would have to be above the x-axis and below the line y equals to 2x. That is because if a point lies somewhere, let's say, above the line y equals to 2x, since going up increases the y coordinate, if you look at the point below on the line y equals to 2x, here y equals 2x, but then if you go up, you're not vertically up, you're not changing the x value, but you're increasing the y value. So right here, the inequality fails. And so that is something that the points lying above the line y equals to 2x are not in our region of integration. Okay, now the second inequality says that x ranges from 0 to 5. X equals to 0 is a vertical line, which is the y-axis. And then if, let's say, x equals to 5 is here, and we draw a vertical line right here, this vertical line consists of all points with the x-coordinate equal to 5. The second inequality, this inequality here, says that the points in our region R, region of integration, lie between the y-axis and the vertical line x equals to 5, because this is where, like in this region, this is where points have x-coordinate between 0 and 5. If we go to the right area, somewhere here, the x-coordinate is going to be greater than 5, and if we go to the left of the y-axis in this area, x-coordinate is negative, so less than 0. And so now we see that the region of integration is the right triangle with vertices at A, B, and C. Okay, very good. So you should imagine, you should think about, a good way of thinking about this region of integration is that for a fixed value of x, so imagine that x is fixed, the set of points that satisfy the inequalities y is greater or equal than 0 and y is less or equal than 2x lie on this vertical line segment. And then if you choose a different value of x, you're going to get a larger vertical line segment or smaller vertical segment, depending in which direction you're going. And so we have all these different vertical cross sections corresponding to different values of x. And it's good to think about the region of integration R is obtained by this moving. Imagine that this cross section is moving when we change the x value from left to right. As the cross section moves from left to right, it traces out, sweeps out this triangle, which is our region of integration. Okay. Now, since we're asked to reverse the order of integration, and in the iterated integral that we're given, the first integration is over y. Now we would want to make our first integration to be over x. And that means we're going to fix the value of y. Fixing the value of y means we will be considering points that have that fixed y coordinate, and that's going to give us a horizontal cross section. I'm showing this in red here. So here's a typical cross section of our region by a horizontal line y equals to a constant value, which I will also denote by y. Okay, so this is cross section is the interval that our integration should be over, and you see that the left end point of this cross section lies on the line y equals to 2x. So we're going to look at the line y equals to 2x, and to determine the x coordinate we will solve for x. X is equal to y over 2, and so the left end point of the cross section has x coordinate equal to y over 2. Now the right end point lies on the vertical line x equals to 5, and therefore x coordinate is 5. And our interval of integration for the first integration over x is the interval from y over 2 to 5. Okay, and so when we go Let's scroll back. Well, actually, it's right here. So the double integral of our function f of xy over the triangle R can be represented by or calculated by the iterated integral, where the first integration is over x from y over 2 to 5. This is the integration over x, and then what is the range for y values? Now imagine all these different horizontal cross sections. What are the values of y that are going to give us a non-empty cross section? Well, these are the values between 0 at the bottom, right? If we go below the x-axis for a negative value of y, we will not have any cross section. We don't have any points inside our region that lie there. Now point C is the highest point in our region. It has coordinates 5 for x, and then 2 times 5, right? C is on the line y equals to 2x. So the y coordinate of C is twice the x coordinate, so it's going to be 10. And this tells us that our region extends all the way to y equals to 10. And so therefore the y range, the range of y coordinates for points inside our region, is between 0 and 10. And so our second integration, which will now be over y, will be from 0 to 10. Okay, and so this iterated integral calculates exact same double integral as the iterated integral that we were given, and we have reversed the order of integration.